Hello, and welcome for lecture 4. This week we'll be covering lists and user input. And so in the previous lecture, we looked into React Native, so we started diving into the components that they give us. We looked at how to style these components. We looked at how to handle some events and how that differs from React and web. We talked about a couple different types of components, one being stateless functional components, and the other being React components with their life cycles. We looked at Expo, which is a library of, a bunch of tools around React Native that allow you to develop much more quickly. We looked at how to import and export things from packages and modules. And then lastly, we looked at prop types, which are a library given to you by React that allows you to keep track of the different props that you're passing to different components. So this week, we're going to talk about React Native much more deeply and in the context of contacts. And so we're going to write a simple application whereby we can add contacts to a list and display those for the user. And so what might we want to implement in doing that? Obviously, we'll need some sort of way to add users, which we'll do towards the end of lecture. But also, we have to have some sort of way to display those users. So if you can imagine on your phone, if you want to keep track of your contacts, you want to be able to see all of them and scroll through all of that. In order to do that, we need to use what are called lists. And so in web, browsers will automatically become scrollable. If the content is greater than the window height, then the browser will take care of the scrolling for you. Unfortunately, this is not true in React Native. For mobile, we actually have to do that manually. So there are a few different components that allow you to do that, the most simple of which is called a scroll view. And so it's just like a normal view, except you have the ability to scroll. We have something that was called list view. If you see that in some source code or maybe some libraries that you're looking into, that used to exist. It still exists, though it is deprecated and is not actively used anymore. To replace those, there are a couple things called flat list and section list, which we'll be looking into in a little bit. And so firstly, we have this thing called a scroll view. So this is the most basic scrolling view. And so it will actually render all of its children before appearing. And so if you can imagine, say you have a view that has a bunch of children in it. If it overflows the page, unfortunately, you can't see the content that's beyond the window, because unlike in web, mobile apps don't allow you to scroll down. But with the scroll view, it will actually do that. It'll render all of its children and then allow you to scroll back and forth. And so let's dive into how that is actually used. And so if you saw in Slack, I posted a link to the source code. It's also linked on the website. And today, we're going to be working through a simple application. And there's a bit of code that is posted right now that will allow you to follow along in class if you so wish. So first thing that we're going to do is look into how we actually create contacts for the first time. So if you look into this file called contacts.js, you have a bunch of things in there. At the very top, we declare this constant called number of contacts. And as you'll see in a second, I wrote this little thing that allows you to just generate a bunch of random contacts. And so it pulls from a list of long first names. And so at line 3 here, we see that there are a bunch of hard-coded first names. If you scroll a little bit farther down, you see a long list of last names. And so the functions that we'll look at in a second will actually pull from that array of first names and that array of second names, of last names. And so some sort of function that we might want to have when we're generating random names is some sort of function that generates random numbers. And so you see here, we have some function called rand, which will generate a random number between some minimum and some max. So you can look into the math that's done here, but basically it's just a little bit of math that generates a random number from 0 to 1, multiplies that by some scaling, and then scales it up to the min. And basically, it does a little bit of math and gives you a number between a minimum and a maximum. Next, we have a function that will actually generate a name. And so we have this thing called generate name, which when invoked, you see this what's called a template literal, which allows us to do some JavaScript, evaluate an expression, and actually add that to a string without having to do some string concatenation. And so with backticks and this thing, a $sign and brackets, we can actually throw inline a JavaScript expression, which will get evaluated and automatically add this to a string. So we see here, we're invoking this random function with the number of first names that we have, -1, which will give us a random first name. We do a similar thing with the last name, and then use this template literal to give us a random name, so first name space last name. We see a similar function down here that will allow us to generate a random phone number. So we see that random function again, giving us a number between 100 and 999, so basically some random 3-digit number. Again, another random 3-digit number, and the random 4-digit number with dashes in the middle, which will give us the 10-digit phone number. We have a function down here which will create a contact, and so the way that we're defining a contact is by giving it a name. The way that we get a name is by calling that generate name function, and a phone number. And the way that we get a phone number is just by invoking that generate phone number function. And so when we invoke this function called create contact, we're given an object with a name and a phone number, and that's what we're going to consider a contact for our examples. I also wrote a little helper function there that we'll use in a little bit, which allows us to alphabetize lists. And so it's just a way of comparing a couple names. So if we pass it a couple contacts, we just extract the name here, extract the name of the second contact, and just compare them. So see which one comes first in the alphabet, which will allow us to do some alphabetizing. And lastly, we have this function which allows us to add keys. And basically what we're doing is we're passing it a value and a key. We're inserting the key. And so we see a couple new things here. One is the shorthand. And so if we have something like that, that's actually shorthand for something you may do a lot, which is this. So the people who maintain JavaScript, who maintain ECMAScript actually, notice that this is something that you see very often in code. And so rather than repeating a key and its value, where the key is the name of a variable, you can actually do that in line. And just by removing the second half, it automatically fills that in for you. We also see this ... val. So we talked about a little bit in previous lectures doing what's called array destructuring. And so by doing ... an array name, it will actually explode that array into a new array, which is helpful for when you want to concatenate to new arrays immutably. It just happens to be that this thing also exists for objects. And so one way we could implement this function would be by hard coding all of those key value pairs. So if we want to do const add key to contact, if it were a function that takes a contact and a key, we could actually do the exact same thing by first doing key gets whatever the key was passed. We could also, we know exactly all of the key value pairs in a contact, right? We have name gets generate name and phone gets generate phone. So we know that every single contact is going to have a name and a phone. And so we can actually just hard code that in. We can say the name gets the contact's name. And we can do the phone gets contact's phone. Which is fine. It does exactly the same thing as this bottom function does, assuming that contact is in the shape. The downside is, what happens if we start to add new keys to contacts? Say we added a first name, last name rather than name, or say we added an address, or a bunch of other fields. We would also need to remember to go add all of those key value pairs into this add key to contact. And so the maintainers of ECMAScript realized, hey, this is something that we're going to be doing very often, so why not have some sort of shorthand to do that? And so what they gave us was this. It's called object destructuring, where you do ... contact, and that will actually take all the key value pairs of contact and automatically do what I had there before for you. And so this is a pattern that you'll see very often. So say you wanted to clone state, or say you wanted to clone a bunch of props. Those are also in the shape of objects. And so this ... notation allows you to do that easily. And so we use that here in add keys, so that when we're passed a value of an object, we can actually just clone that object very quickly and append the key. In the very final line, we see what we are exporting as the default export for this module. We see create an array of length number contacts. And so at the very top, rather than hard coding in some value here, we just said, hey, give us some sort of number where we want that number to be the number of contacts that we eventually export. And then we go ahead and use that there. And then we go ahead and map add keys to it. And so array.from is a function in JavaScript where it allows you to take something of array-like shape and turn it into an array. It takes another argument, which you map over these things. And so by passing in length num contacts, that's the shape of an array object, because every single array has a .length value. And so by passing in this object called length num contacts, it's a shorthand way of just creating an array of arbitrary length. We then map over it create contact. And what does create contact do? Well, it doesn't care what objects are passed to it. And so in this case, when we use map, we really don't care about what the value of the array values are to begin with, because we're just going to replace those with random contacts. And so by doing array.from length of number of contacts, that creates an empty array of length number of contacts, which we declared at the very top. We then map create contact over it. So now we have an array of length and number of contacts filled with random contacts. And then we go ahead and map over that to add keys. And we'll see why this is valuable in a second. So any questions on this little helper file that I put together? Basically, all it does is create a length, an array of length num contacts, so 1,000 here, and then goes ahead and fills that with a bunch of contacts, where we define a contact as a name and a phone number. So let's go ahead and first try to add that to some sort of application where we can display all of these contacts. And so if you go ahead and run the project that I have linked to, all it is a blank screen that allows you to toggle the contacts being shown. And so now let's actually look at what the application is doing. And so if you open up this application, we see the usual imports at the top. So we're importing React from React. We're importing a bunch of views from React Native. One of those is scroll view, which we'll be looking at in a second. We see importing constants from Expo, which, as we saw in a previous lecture, allows us to have some padding for the status bar at the top. We're importing contacts from contacts, which is the file that we were just looking at. And then we're declaring a new class called app. And so the first thing that you see that looks different than what we've seen before is this thing called state. We've talked about state extensively, but in prior lectures when we look at state, we always do that in the constructor. There's actually another shorthand that we see here that is very useful for when you want to use constructors that all they do is add state. And so as we saw in previous lectures, when we were doing something like binding an anonymous function like this to some sort of class property, we can actually also do that with state. And so this is a shorthand which actually will compile down to this. And so as we saw earlier, all I had was state equals this. And what happens when you compile this is it actually compiles into this. It takes all of the class properties that we declared and moves that into the constructor. And so you see that we have this toggle contacts that actually gets moved up into the constructor during transpilation. And so we see this dot contacts, this dot toggle contacts equals some anonymous function like this. And so when this actually gets compiled, it all actually turns into this. But since we're not actually doing anything in the constructor other than calling the super, then why not just use the class properties so that it's easier to read? And so if you are looking at other people's code or maybe reading libraries, most people actually do something like this, just because it's slightly easier to read. And so we see toggle contacts is a function that we defined. And all it does is it toggles the show contacts Boolean, which we store in the state. And finally, we see render. As we talked about extensively last lecture, components, their sole purpose is to render things to the UI. And so the render function here is just returning a view with a button that toggles the contacts. And right now, we're not actually doing anything with that value. But we're actually going to turn this into an app where we can actually show the contacts on the screen here. And so let's try to do this in a way that we using things that we have learned in prior lectures. And so if we wanted to display all of these contacts on the screen, how might we go about doing that? So in previous lectures, we've learned a few different components. We've talked about buttons, we've talked about text, and we've talked about view. And so using those, we can sort of start to create this application where we can see what contacts we have. And so using things that we've seen in previous lectures, we would use a view and wrap a bunch of text to show those contacts. And so right now, we've imported contacts, which is a big, long list of contacts. And we're going to go ahead and display that in that view. And so how might we go from an array of contacts to a bunch of people in that view? Are there any functions that we've learned thus far where we take an array and turn that array of values and turn that into something like an array of elements? Yeah? Yeah, map would be a great example here. So what map does is it takes an array, and for every single value in the array, it runs it through a function and takes the return value of the function and returns a new array. And so right now we have imported contacts from contacts, which as we saw is just an array of people. And if we are able to turn that into an array of elements, we can actually use React to render those elements. And so let's actually do that here. So we can do contacts.map. And what do we want to do for each of these contacts? Well, maybe we should render some text to the screen. And so let's just start with this, where the text is the contact's name. And we see that it's rendering. So I see 1, 2, 10, maybe 50 or so contacts. But when I try to scroll, nothing happens, because as we saw earlier, unlike in mobile, when we have views that are larger than the viewport, there's actually no way for React Native to automatically add this scrolling for you. And so we have to actually have some additional components to handle that. And so as we talked about, we have this thing called a scroll view. And so this is the most basic scrolling view, and it will render all of its children before appearing. If we want to render an array of data, as we saw, we could just use that .map function. And so now let's try just replacing this view with a scroll view. So all we changed was replacing view with scroll view, and now we have a view that scrolls. One thing you notice is that we have a warning at the bottom of the screen. It says each child in an array or iterator should have a unique key property. So what does that mean? So this is actually something that React uses for performance reasons. Because if you can imagine, say we have a list of items. That list is Jordan and David. So in previous lectures, we talked about this thing called the React tree, or the React virtual DOM. And what that is React's way of maintaining all of its components that it's rendered in some tree-like data structure. And so we might have something like a list. And then within that list, we have this thing called Jordan and this thing called David. So in previous lectures, we talked about how when we add something or when we re-render, React will actually recalculate this DOM and then only do what's necessary to, for a new re-render. And so say we added somebody to this list. So say we add Yawan to this list. In this example, it's pretty easy because we have Jordan is where he was before, David was where he was before, and now we just add Yawan to the very bottom. And so React can see, oh, Jordan, David, easy. Let's just add Yohan. And so in this example, it's fairly easy to just tell, oh, we just added somebody to the bottom of the list because the top two stayed the same. But say rather than adding Yohan to the bottom of the list, say we actually added him to the top of the list. So now when React does its diffing, so when it compares all of the nodes, it says, oh, we used to have Jordan in position 1, and now we have Yohan in position 1. That's not good. We should update this to be Yohan. What's in position 2? Oh, position 2's now Jordan. It used to be David. We better update that. And now we see in the third position here, oh, that's new. We better add David. So does anybody see why that might not be ideal? There was actually a shorter route, right? Rather than replacing Yohan for Jordan, and rather than replacing David with Jordan here, we could have just added Yohan to the beginning of the list there. And so if you could imagine, if this list is 1,000 things long, it might not be trivial to know exactly where things should be moved and where things should actually just be replaced or updated. And so React actually implements this by using these things called keys. And so how can we tell that this Jordan is the same as this Jordan here? What if we have multiple people in the list called Jordan? And so in our example, we have a bunch of contacts. What if a few contacts had the same name? That might be true. We can pretty much guarantee that multiple contacts won't have phone numbers, but won't have the same phone numbers, that is. There's no way for React to inherently know that, oh, this is a unique key in the object that we have here. And so what it has done to solve this is it actually uses this thing called a key. And so anytime we have a list of data, React says, oh, one of the things in that, one of the props that you should pass for each of the things in the list is this thing called a key. And so if we see here in this example, say we had, back up a few, say we had given Jordan and David a key of 1 and 2, and now we added Yohan at the top. React can just see, oh, look, what used to be key number 1 here, what used to be key number 2 in this place, we can see that they've actually just moved to the second and third places here. And so we can actually reuse that and just add Yohan here. And so React can do the thing that was actually the most efficient, and the way it does that is by comparing keys rather than trying to figure out exactly which value is the most important. And so that's why, in this example here, we passed this, this element a long list of elements with names. And React is complaining, hey, I can't do the most efficient thing because you never told me what keys there are. And I'm sure that in this list of 1,000 names, maybe there's 1 or 2 that repeat. And so React, when we want to update later down the line, it doesn't know what it should be doing with those nodes. And so it says, hey, just as a warning, you should actually pass me some keys. And so if you actually look at the code over here, we actually assigned keys. And so when we created all of those contacts, we mapped this function called assign keys. And as you recall from previous lectures, map passes 2 values to each of the function invocations, the first one being whatever the value is in the array, and the second one being the index. And so we're actually using that index as the key here. And so now in this example, we can say, hey, React, we have keys for you, and we'll actually pass it to you. And so we can say the key is the contact's key. And so by doing that, we pass React a key for each of the things in the array, and now it can do its magic and not show us that error. So any questions on passing arrays to elements and why keys are useful? So let's actually build out this app a little bit more. So right now we're showing our users a bunch of contact names, but that's not very helpful for an app that's trying to tell people their phone numbers. And so let's also display the phone number. So we'll probably need to wrap this in a view. And this also provide the contact's phone number. And so now when we map through the contacts, we create these views, and we still pass that key like we were before. And inside that view, we're passing the contact's name and the contact's phone number. And so now when this re-renders, we can see a list of names and phone numbers. And so our app is starting to come into place. So does anybody see an opportunity for making this code a little bit more readable? Right now, every time we're mapping over these contacts, we're using this, this element that we're declaring inline. But we can actually make our code a little bit more readable by, rather than having just an arbitrary few lines creating an element here, we can actually abstract that out into its own component. And so as we talked about in previous lectures, React allows us to break our code up into smaller components and allows these components to be pulled in to other components. And so rather than having these 4 lines declared in line here, let's actually create this concept of a row. And so now we have a stateless functional component, which is just a component that takes a function that takes props and returns an element. And so right now we have this thing called contact.key, contact.name, contact.phone, but instead we should be looking at the props. And so let's call this props.key, props.name, and props.phone. And so down here, we can actually just use this row component. And so we need to pass to the row component the props that it's expecting. And so that are what? The key is the contact's key. What else was it expecting? The name, which is the contact.name, and the phone, which was the contact's phone. And so basically, we're taking all of the keys of each contact and passing them down, the exact values down. And so just actually like we saw earlier, how you can do ... the object, which will spread out all of the key value pairs of the object and pass it to a new object, you can actually also use that inline in React elements. And so rather than just being very explicit in declaring, oh, let's pass key, which is the contact's key, name, which is the contact's name, and phone, which is the contact's phone, we can actually have a shortcut. We can actually say for every single key value pair of the object called contact, pass those in as props. And so here again, you see that ... notation, which is a very convenient way of taking a bunch of key value pairs of an object and passing them either to a new object, as we saw earlier, or to a React component, as we see here. And so if we save and run that, we see key is not a prop. Oh. So one caveat about these keys here is that you can't, having it as a prop here in its own component is not very helpful for React, because React's actually looking at the element, not the the element that you map over, not necessarily the elements that that element returns, which is a long-winded explanation for just saying you should do this. So we need to pass the key in to this element rather than using it as a prop up there. Actually, which we did. It was just complaining about. So we were, in fact, passing the key because it gets spread out here. But since I was also passing it into the view up there, the view is saying, hey, I'm not expecting this prop called a key. And so that should have silenced the warning over here. And so we see nothing visually has changed in between the two examples. All we did was just abstract out a smaller component called row. We can actually take this a step further in cleaning up our application. So why do we feel the need of declaring this component called row inside app.js? We can actually start to break these things apart and actually have a new file for row. And let's do that together. So I'm going to create a new file called row and open it here and just cut and paste this. And let's say import row from /row. Save and quit. It's going to error for now because we actually haven't finished writing row. And so first, we need to import a few things, including React. We need to import view and row and text from React Native. And lastly, we need to actually export row. And so now, again, we're in the same exact place in terms of UI, but our code looks slightly different. And so why might we have wanted to split this row component away from this app? So open to the audience. Why might we consider that a good thing? Removing this, what's only 5 lines of code, this component out of this file and moving it to a new file. What benefits do we have there?
Reuse it for different things?
Yeah, we can reuse it for different things. So certainly if we have a bunch of different new files, we can actually pull in a row to all those files and reuse it. And that way, if we wanted to change exactly what a single row looked like, we wouldn't have to do that in multiple places. Additionally, it's much more scalable. So imagine a company at maybe Facebook size, where Facebook has talked about how they have over 30,000 different components. Imagine having 30,000 components all defined in a single file. That could get quite unwieldy. And so by splitting them out into files and splitting those files into smaller files, we can actually have a bunch of bite-sized logical pieces which compose together to create one more complex piece. And so as we talked about in previous lectures, how React allows us to break down a large complex problem into a bunch of small ones, this is an example of just taking a bite-sized small problem and solving it, and then using that bite-sized small problem in a slightly larger problem. And so as you'll see in a bunch of lectures is that rather than solving a big problem all in one go, it's much easier to solve a bunch of small problems. Great, and now let's make this look a little bit better. So we have what's pretty hard to read, and we can just throw some styles on here to make this look better. And so the way that we do that is by importing style sheet and then creating styles here. So let's just call this a row and maybe pass in some padding. And call that it. And so now it's slightly easier to read. So we have this button that is supposed to toggle the contact list, but it currently isn't doing anything. And so let's actually add that functionality to our app. So we already have the logic where we have this Boolean flag called show contacts. We have the logic which will flip that flag. And so every single time this toggle contacts function is invoked, it will update the show contact state to be whatever the opposite of whatever the previous one. And we already have a button here which invokes that. And so let's actually figure out some way of using this scroll view and flipping it on and off. So there's a few different ways to do that. We could do if the state is telling us to show the contacts, then we can return one thing. And if not, we can return something else. And so here you might imagine that we cut and paste this exactly. And if not, we can do that. And that would work perfectly fine. So we can click toggle contacts, and we'll toggle the contacts. If you click it again, it disappears. Why might that be slightly unideal? What if we started adding some complexity to the app? Maybe we added a button for adding contacts. Maybe we added a button for sorting the contacts. Where would we have to update the code? We'd have to update it here. We'd also have to update it here. And so for every single conditional render that we do, we'd also have to update that for anything that we want to add. And so there's actually some sort of shorthand in order to do that. We could say in here, using JavaScript, we could say if this dot state dot show contacts, then return this thing, otherwise return null. And so this is called a ternary. You may or might not have seen it before, but it's basically saying, given some expression, if that evaluates to true, return what's after the question mark. Otherwise, if it returns a falsy value, return whatever is second here. And so this would be a slightly more legible way of doing exactly what we did before. So in other words, take the value of this .state.show contacts. If it's a truthy value, then return whatever is after the question mark, so the first thing, which is the scroll view. Otherwise, return null. And if you null, when you pass null to a React element, it just renders nothing. And so this, again, does exactly what we had before. But it turns out there's even a better way to do this. So we could actually just do this.show contacts and this. Because the AND operator does what? If the first thing is true, it returns whatever is next. If the first thing is false, it just returns false. And so false and null both just disappear when you're trying to render those in React. And so this is just saying, hey, if this is true, return this thing. If it's false, just return false. And it's the same as rendering something null. It's just non-existent. So this, again, does the same exact thing as we did in the previous two examples. But this, in my opinion, is the most legible. And so if we hop over to the UI, we see, again, that it does the same thing. But notice, as I click toggle, it takes 2 or 3 seconds to render all of these contacts. And say we have a very popular person, and they actually have 10,000 friends. Now when we toggle contacts, it's 2, 3, 4. It's going to take a few seconds. And so why is it taking so long? So as we saw, scroll view will actually render all of its children before appearing. which is somewhat unideal if you have a very long list to render, because even though JavaScript and React are extremely fast, when you want to take 10,000 elements, map over all of those, create 10,000 more elements, and render all of those, it can take upwards of 20, 30 seconds. And only now has it recently rendered, which can be a problem. Say you have a very popular person with 10,000 friends. It'd be annoying for them if every single time they want to open this app, it takes 20 or 30 seconds to render. So let's look at a way to making that faster. And if you want to check out the docs for scroll view, they're linked in the slides. So there's this thing called a flat list. So a flat list is a very performant scrolling view for rendering data. And what it does is it's called virtualized, which it only renders what's needed at the time that you're viewing it. Or in other words, only the visible rows are rendered in the first cycle. And so in this example here, well, it's going to take a few seconds. Let's actually, in this example here, what happens when you want to render a flat list is it will only render these elements. And as you scroll down, it will say, oh, I need to render more elements, and go ahead and render those one by one. And so as you can imagine, when you want to create that list for the first time, it only has to do 1, 2, 3, 4, 5, 10 or so elements, which should be blazing fast, at least a couple orders of magnitude faster than rendering 1,000 of them. And what this means is, as you scroll down, what used to be at the top might actually just be recycled. It might be used again in some lower cell, which means that any rows that leave visibility might be unmounted. So if you're maintaining component state in each of those, you have to figure out some sort of way to maintain that outside of the component itself. And in a future lecture, we'll talk about some data handling libraries that allow you to do that. But for now, just avoid using any component state in these rows. So how do we use this? So we have to pass a couple things. We have to pass the data. And so as you can imagine, if we have some sort of list that's rendering data, it needs to have the data. And we also need to tell it how do we render each of these data points. And so we pass an array of that data and a render item function. And so this render item function is just a function that takes an item and returns an element, similar to the row component that we declared earlier. And so let's go ahead and use this. So here we have a scroll view, but let's actually call this a flat view instead. And so unlike the scroll view, where the scroll view, we actually declare all of the rows as children, for the flat view, we're actually going to pass props to, and flat view is smart enough to know, hey, given these props, I know how to render all of my children. And so I can go ahead and do that in a very optimized manner. And so we can actually just get rid of this here. And let's have a flat view. We need to pass it data. And so the data are going to be the contacts. And we also need to pass it this thing called a render item. And render item takes some sort of object and returns whatever we want to render for that item. And so for each item, we want to render a row. And what are we passing to the row? Well, we want to explode, we want to object spread something. And so let's just do object.item. And so I only know this because I read the docs, but the object that's passed to the render item function actually has this thing called an item as part of the object. And so I go ahead and use that here. And so we've passed it render item, and we've passed it some data. And I believe that is all that we need to pass it. And so let's see what happens. let's actually real quickly sanity check this. Let's actually just declare this outside the function and see if I made a typo. Flat list. And I also imported flat view instead of flat list. All right, now we see that it goes ahead and renders almost instantly. And so as we see, again, pretty instantly. And so let's actually scale this up and do again that example with 10,000 contacts. And again, we see that it is no slower in rendering those 10,000. And I put that in air quotes because really it's only rendering what's on the screen now. And as you scroll down, it actually just will render the things as we get to them. So one downside or upside, depending on how you look at it, of flat lists is that it only updates if props are changed. And that's actually an optimization done by the React team so that it doesn't necessarily re-render. And so let's actually add a feature to our application here. And so right now, say I'm looking for a friend named Aaron. There's really no way that we've organized this so that I can find Aaron easily. And so one thing that we can do is we can actually sort this alphabetically. So if I want to find a friend named Aaron, it's very easy because he's at the top. His name starts with an AA. And so let's add this feature to the app. And so in order to do that, we need to have some sort of button that's going to sort things. And we're going to have to actually sort things as we go. So let's define a function called sort. And what it does is it will take the list of contacts and go ahead and sort it. And so let's do this.setState. And take the contacts, take the previous state's contacts, and invoke this thing called sort. And so as part of the array prototype, all of arrays have this method called sort. And sort will take a function that compares two values and just will sort them in increasing order. And so for things like strings or things like numbers, it's very easy to compare those because JavaScript knows, hey, given two numbers, it knows to use the greater than or the less than or the equals to compare them. And same thing with strings. But for objects, it's non-obvious to do that. And so that's actually what this compare names function here is for. It's for us to compare these two contacts while we alphabetize them. And so let's actually import that into this function. So we want to import contacts, the default export, and also this thing called compare names from contacts. And let's go ahead and sort that list here. And so we pass into sort that function. And so when we invoke this thing called sort, what we do is we take whatever the previous state contacts were, and we sort them. Obviously, we need in state our contacts. And lastly, we want to have a button that will sort things. And then rather than passing contacts here, let's do this .state.contacts. So since we're so worried about performance right now, there's actually one big performance issue that we have right now. So when we declare render item, what we're doing is we're passing it a function that we're creating right now. And so every single time this component re-renders, a new function is created. And so let's actually move that into the class. That way, we can just pass that reference. And so let's say render item is this. And here we can just pass this dot render item. And so now we see that we can toggle the contacts, and we see that we can sort. But when I click sort, nothing actually happens, which is a very strange bug, because if we toggle again, now we see that everything's sorted. And since I was looking for my friend named Aaron, fortunately, I have a lot of friends named Aaron, and they all are at the very top. Let's look at that again. So I can see my contacts. They're all out of order. I click sort, which is supposed to sort them, but nothing actually changes. But if I then toggle on and off, all of a sudden, everything is sorted. Very interesting. And so we talked about how flat list, it only updates if props are changed. And are we actually changing any props? So we're passing down as contacts a sorted list of the previous contacts. But is that actually changing anything? So if you look at the documentation on array.prototype.sort, it actually does this in the same array. It actually mutates that array such that all of its values are sorted. But it doesn't actually create a new array itself. And if you remember back in previous lectures, how do we compare objects? They're actually just stored by reference, right? And so since this is the exact same array, when you pass it down to the child down here, the reference doesn't actually change. And so as we saw, flat list doesn't update if its props don't change. And so since we're sorting this in line, the array itself doesn't actually change. And so if we want to do this correctly, we actually need to use what's called immutability. And so immutability is this concept by which if we're given some sort of object, or if we're giving some sort of value, that value is guaranteed to not be mutated. And if we want to change that value, what we have to do is we actually have to create a new value that's very similar, but we change what we wanted to change there. And so in this example, rather than using the same array and sorting within that array, we actually want to create a new array. And so again, there's a quick way to do this by using that ... notation. So if we create a new array literal, so just two brackets, that's creating a new array. So that took care of the create new array part. If we do ... prevstate.contacts, that says, all right, for every single value in prevstate.contacts, clone that into a new array. And so to be very explicit, for each of the values in contacts, those objects have not changed at all. They're still the exact same objects, exact same object references, but they're put in a brand new array. And so when we pass this new array down, it's a brand new array, and it will re-render. And of course, if we do .sort on this new array, since that flat list hasn't seen this new array before, it will go ahead and re-render. So now if we save this, show our contacts, and sort, it goes ahead and works. So any question on flat list, or virtualized, or scrolling list that we've seen thus far? Yeah?
In the funky syntax, you pass it option data
Can you repeat? Can you repeat the question? I missed the last part.
For render item,
Mm-hmm.
you're giving that an object as part of its argument. What is that object?
Right. So the question was, for render item, it takes as an argument the object. And what exactly is this object? Well, we can actually just look at the docs, and it tells us. So in the docs, if we look for render item, it tells us exactly what is passed as arguments to render item. And so as you see here, render item is invoked with the item, which is an object, as well as a few different things like index, separators, which we don't care about. We really only care about the item. And so since I read the doc page, I know that one of the keys that is passed to render item in the object is called item. Does that answer your question? So the reason that I have object here and object.item is because I know that the object passed to render item has a key called item, which refers to the item in that data.
Okay, and that object is just passed by React Native.
So flat list takes care of passing the object for you and creating the object and doing all of that. Really all we care about is the fact that we have the item passed here. And actually there's shorthand for that as well. Rather than passing this object, we really only care about the item. So just like there's shorthand for a lot of things, so the analogous, so when we wanted to create an object, if we have a variable called item and we want to create an object with a key called item where the value is item, all we had to do is this. You can actually do that in reverse. Say we're passed an object with a bunch of keys and we only care about the one called item. We can actually use the syntax, which will create a new variable called item and extract that key for you. So another shorthand that we see is rather than being passed an object and only using object.item here, we can actually what's called destructure that object, pull out item, and use that there. And again, the only reason that I know that this key called item exists is because the documentation for flat list told me, hey, we're going to create this object for you, pass down this item, and you just can use that item there. And so that's all abstracted away from us. We don't really care about anything else. We just care that the item that's passed down is called item in this object. Yeah?
So the thing that's passed in, isn't it what's in the data, like the contact object?
So the data, so the question is, so I'll just answer. So the data is an array of arbitrary things, and each item that is rendered takes one of those values, puts it in a key called item, and passes it to whatever the render item function is. And so we defined it such that it takes an object with an item key and passes that into our row component.
Okay, so and then you did triple dot item. So what is the item then? Is it referring to the object with the key item?
So what is item here is the question. And so item here is an object in the shape of name and phone, where name is of type string and phone is also of type string. And I know this because I know that each of the data points inside of data is of this same shape. So if we open so up here in contacts.js, when we created that array, it's an array of contacts where each contact is a name and a phone number. And so that array is passed into here when we import it in. And then that array is the same data that we're passing to flatlist. And so this .state.contacts is what we exported from here, which is an array of names and phone numbers. And so what flatlist is doing for us is it's automatically taking all of that data. So the data is a bunch of objects of this shape. And it's lazily, and when I say lazily, it means only when it's in view, rendering each row or each item. And so for each item, it needs to know exactly how to render it. And so what we're passing is a function called render item, where the render item takes a bunch of configuration, one of which is the item itself, because it needs that information in order to know what to render, and then passes that into whatever we want. And so we declared up here that when we want to render an item, we take whatever information is, so the value of the array itself, and just pass those into the component that we called row. Does that make sense?
Why do you put the curly brackets around the item, and you didn't do that before?
Here?
Yeah.
That's just that special notation, so you can ignore that. So that's the same as this, which is the same as this. So that was just a bunch of shorthand for this. So we know that we're passing in an object. We know that the item that we pull out of data is object.item. And we know that that item has two keys, name and phone. And so we can just say name is object.item.name, and phone is object.item.phone. And if you're reading source code from any libraries that you see, most people will use all of JavaScript's shorthand, which include pulling out item automatically by using that shorthand there, and using all the key value pairs automatically by doing that ... destructuring notation. But this effectively does the same thing. Does that make sense? Great, let's take a 5-minute break, and then we'll go ahead and look at this and other lists after the break. Hello, and welcome back. So before the break, we were talking about the lists and the list components that React Native gives us. And we showed an example for flat list. And one question that came up in Slack was, how come the warning for keys was not popping up, even though we were not being explicit about the keys in the example here? And so one thing I left out when I was talking about the shape of items here was that key exists, which was a number. And if you look at the flat list docs, it actually automatically extracts the keys for you. And so if you have a key value in the objects that you're passing in that data array, then it will use those for the keys. And if you want to use something other than a key property, then you can pass this thing called a key extractor, which is a function, to flat list. But for our example, since each item had a key, then it worked and automatically extracted that key for us. So great example, great question from Slack. So another scrolling component is actually called a section list. And so if you open up your actual contacts on a phone, it will actually give you sections with section headers. And so this component is exactly like a flat list, but we have additional support that will automatically use those section headers for us. And so instead of a data prop, we actually just define sections. What do those sections look like? Well, each section has its own data array. So unlike in flat list, where we had an array called data, we now have an array called sections, where each section is an object with its own data array. And each section has the opportunity to override the render item function with their own custom renderer. Say if you wanted to have different colors or different backgrounds for each section, you could do that by overriding the render item function. And for section headers, we just pass a separate renderer. So just like we defined a renderer for the items, we just also define a renderer for section headers. And so let's take a look at what that looks like. So if we replace flat list with section list, and we passed, rather than data, we pass sections, where sections is actually an array of sections. In this example, let's just hard code those sections where one the data is this .state.contacts, and let's say the title or something. We can call this whatever we want. Let's just call it A. So we're passing it a render item, which tells it how to render a particular item. We're passing it the sections, which each section has its own data, and each section has its own title. But we're not telling the section list exactly how to render those sections. And let's go ahead and do that. So let's do render section header, it's called. And let's do render section header. So now we have to go ahead and define that. And let me check my notes to see exactly what that object looks like. So just like we have an object here, we're passing an object down. And just like this object in the render item has this thing called an item, this thing called render section header has a section. So let's just pass it text and do obj.section.title. And again, the only reason that I know this object.section key exists is because I looked at the docs and wrote it down. And so I know, so just like this object has this thing called object.item, which refers to the item itself in the data, this object has object.section, which refers to the section that we're passing down here. So we refer to this object here. And so since that object has a key called title, we can go ahead and use it in here. And so now that is more or less complete for section list. We give it a way to render each item. We give it a way to render each header. And we tell it what the sections are. And so in this example, we have a single section that's an object with the title called A, and data being all of our contacts. And so if we go ahead and show that, save it. And there's a syntax error somewhere here. If we go ahead and run that, we can see that we have a section header here, just the A, and then following it are all of our contacts. And again, this is another one of those virtualized lists where it lazy loads. And so if we toggle it, it immediately loads even though there are 10,000 of them, just because it's only, again, rendering what we see on the screen. And as you see here, that A is that section title. And so let's actually improve this a bit. And so right now we have hard-coded the fact that we have a section called A with all of our friends down here. But what if we actually wrote a function that figured out people's appropriate sections? And so everybody whose name starts with an A should be in the A section. Everybody whose name starts with a B should be in the B section, and so on. And so let's go ahead and write a function that does that. So how might we do that? So first, let's clean up our code a little bit. Right now, we have this section list down here. But this is another example of a time where we can abstract another component out of this. And so let's create this thing called our contacts list. And into that, let's just cut and paste this section list. Let's just save this for now so we have some room. And so here, let's create this thing called a contacts list, which is a stateless functional component. So it takes some props, and it will return this. But before that, let's do some things. Actually, first, let's complete this example. So first, we need to import React. And we need to import section list. And lastly, we need to export this, because without exporting it, we can't import it into our main application. And so let's call this props.render item, props.render section header, and props.contacts. And so now we have 3 props that we're passing down. So it might start to get a little bit difficult to keep track of all of these props. Does anybody remember something that we discussed in a previous lecture, which will actually self-document all of our props for us? There's that package called prop types. And so if we import prop types from prop types, this is that package that allows us to self-document things. So if we forget to pass down a prop, or we don't remember what a prop should look like what data type is it, we can actually use prop types to, 1, check at runtime, are we passing the correct props? And 2, to just document for us so that when we open a new file, we know, oh, we should be passing this, this component these particular props. And so again, the way to do that is by adding this key to contacts list called prop types and defining an object with those key value pairs. And so we're expecting something called a render item, which should be a function. We're passing down render section header, which again should be a function. And we're passing down some contacts, which is an array. And so now React will tell us if we're passing down the wrong props. And so let's go ahead and use this contacts list in our application. So here we want to import prop contacts list. Contacts lists. And down here, let's go ahead and use that. And what props are we passing down? We're passing down render section header, render item. We're passing down render section header. And finally, we're passing down contacts. And just for fun, let's actually pass down an object for that. And so we'll see if we pass down an object, 1, everything's not going to work. And 2, it's telling us, hey, failed prop type. We expected contacts to have type object, or we passed contacts of type object when we were actually expecting an array. And so again, prop types, as we showed last lecture, is just a way for us to catch bugs. So if we're passing down something that we think is of one type and is actually of a different type, it will catch those bugs for us and tell us, hey, we're expecting an array here. And so for contacts, we should actually be passing down the contacts. And so now we are back to where we were before. Though there's one thing that I think is a little bit strange about this example. So does the application really care what render item is? And does the application really care what render section is? In a way, yes, but where should that really be defined? What component actually really cares about render item and render section header? It really is the context list, right? Because the application, this doesn't really have anything to do with the logic in app.js. And same with render section header. The fact that render section header is just some text doesn't have anything to do with the other logic in app.js. And so what might be a better place to implement this logic?
In the other file.
Yeah, in the file called context list. And why might we want to do that? So imagine down the line, imagine down the line we have a very, very complex app with contacts and everything. And say we were saying, oh, this is a cool contacts list, but I think the row's a little bit ugly. Let me go change that. And say it wasn't you. Say it was a friend who's helping you on this project. Where are they going to turn to for changing that? They're probably going to look at the component that renders it, right? And so by having the render item, which is arguably something that the context list is solely responsible for, having that logic in app.js is going to lead some problems down the road for 1, maintainability, 2, readability, and 3, scalability. And so all of this just goes down to the fact that render item is really something that the context cares about and not app.js. And so how might we go about solving that problem? Well, we can just move that to the other file. So let's take those, cut and paste that here. So what we did is we removed those 2 functions. We can remove the render section header here. We can remove render item here. And now all we're doing is we're passing contacts list the contacts. Which makes sense, right? What should contacts list need to render? Just a list of contacts. And that makes sense. So its API is saying, hey, I can render a contacts list. All you have to do is pass me the contacts. And so by removing the logic that's not unique or not necessarily cared about inside of app.js, outside of app.js, it now makes more sense in like a mental model. So everything that's needed for context list to render should be implemented in context list. And so now let's finish this. So now I just created those 2 functions. So we have a function called render item, and it's the same as it is before. It's an object that returns a row, and of course we had to import row. And then we have a const called render section header, which is the same as it was before. It's an object which returns some text. And of course we had to import in text. And so now we can just go pass that in there rather than looking for its props. And now if we save that, again, we're in the same place in terms of UI, but our code is much, much neater. If you look at app.js, it's returning something very simple. A couple buttons which are needed, and a contacts list, and we're passing the contacts. And so again, now this bite-sized piece of the application, just this layer here is very simple. We have a view with a couple buttons. We take care of those buttons logic in here. And then we have a separate component called contacts list, and we pass the list of contacts. And so this is a very simple way of stating our app. And if we want to get into the implementation details of contacts list, we can just look at the contacts list component. And in here, we have the logic necessary for contacts list. We're defining what it looks like to render a single item. We're also telling the section list exactly how we should be rendering a section header. And of course, we're just looking to our props for the contacts themselves. But then what the heck is a row? And so again, that's another bite-sized small piece of our application. So if you want to look at the exact way a row is implemented, then you can just look at the row file. And here, it's another simple problem that we've solved. So a row is just a view that tells us some name and a phone number, and of course styles it a little bit by adding some padding so everything is not squished together. And so what is turning into a more complex app is actually just a few different simple files. And so as you work on your next project, or personal projects in the future, you can start to use these paradigms where you have a big complex problem and break it down into smaller components such that each one is very maintainable, each one is very readable. And so if you want friends to work on that with you, it's very easy to tell them, oh, if you want to change this part of the application, just look for that particular file. And so now let's actually tackle that hard logical problem where we have an array of contacts and we want to split that into a bunch of sections where each section has the section header is defined by the first name of the contacts. So how might we do that? Well, first we're going to have some logic that we're going to want to do before we return the section list. And so first we might want to say, take props.contacts and split that up into that this shape where we have an array of objects separated where the title is, again, the first letter of every single contact in its data. Can anybody think of a good algorithm to do that? So the way I would implement it myself is I would go through that array, turn that into an object where the keys in the object are the first letter of the values in that. And then go from that shape where it's an object where the keys are letters and the value is an array of all of the contacts with that letter, and turn that into this shape. And so let's go ahead and implement that algorithm. And I'll go a little bit quickly for the sake of time. So let's do contacts by letter. What that does is it takes props.contacts and reduces it, where the reduction is taking the object, which is the object that we eventually want to get to, where it's the keys are the letters and the values are an array of all of those contacts, and it takes the next contact. And we want to, of course, start with an empty object. And so for each contact, we want to grab its first letter. So we can say take contact, the very first letter in the string, and uppercase it. And of course, we want contact.name. So contact.name, so grab its name, look at its first letter, and uppercase it. And so now we've extracted the first letter of each contact. And then what? We want to add that to that object. So we want to return some sort of object where it maintains all of the previous keys of object and appends this particular contact to the key which matches its first letter. So that's a little bit of work to do, and we can actually do that all in one line. So what have we learned today, which is a quick way to clone all of the old keys of an object? We can use that object spread. And so now all this is doing is just returning the same exact object, but in a new immutable object. But let's actually add this contact. So we want the key to be first letter. And so you can wrap it in brackets, and just like this will evaluate 0 to become a string. This will evaluate this to become the key. And what do we want this value to be? Well, it's going to be an array. And the array is going to be all of the keys that used to be in that object. And so now we've again, this actually returns pretty much the same object as before. So it's cloning all of the keys in object, except it's overriding the one where the key is the first letter that we extracted from here. And what are we setting to be that value? Well, we're setting a new array, and we're setting that array equal to basically everything that was already that object where the key was the first letter. And so this is starting to get complicated, but basically it hasn't done anything yet. We've just cloned that object. And so how are we going to actually add that contact to this array? Well, just like that. Still with me? So now we're returning this object, and we're building it up as we go. And so we want to say retain all of the previous keys. So say we have A through Z already. Make sure we don't lose those. So go ahead and clone that object. But override whatever key is equal to that first letter. And so the first letter, again, is just uppercased the first letter of each contact. And so we override it with a new array, where that new array is the old array, but add that contact. Yeah?
So if object first letter is undefined, does it still work?
Great question. No. So the question was, if objects with the key first letter is undefined, so if this is undefined, so say this is the very first iteration, it's an empty object, and so object A does not exist. Will this still work? No. So we have to actually handle that corner case still, but great catch. And so let's actually handle that corner case. So what happens if it's undefined? So now we'll say, oh, if it's undefined, just consider it to be an empty array. And so when you spread the empty array, then that's nothing, and then contact. And so you're left with an array with the contact in it. So I'm going to wave my hand at it for now, since we're running a little short on time. But if you have any questions about this function, please feel free to Slack or email me, and I will talk everybody through it. And so now let's go from the contacts by letter to something of the shape title and data. And so how might we do that? Well, we can actually just map over those keys and create that. And so I'm going to go a little fast in the sake of time. So object.keys takes all of the keys of an object in an array. So now this here is an array where the keys are the keys of whatever the contacts by letter. So it's going to be something like A, B, C, D, E, F, G, but leaving out things like X if we have no friends whose name begin with X. Let's just sort it, just in case it's not sorted already. So say it's something like A, C, B. We want that to be A, B, C. So we can go ahead and sort it. And then let's run a map over it. So for each letter, what do we want to do? Well, for each letter, we want the section title to be that letter. And so we can do the title here is the letter. And the data, we actually want to be the data that we created up here. And so how might we do that? Well, we can just get the contacts by letter and grab its key where that key is the letter. So again, going a little bit fast because we're short on time. But we're grabbing all of the keys of contacts by letter. So that's going to look something like the alphabet. Sort it to make sure it's in the correct order. Then for each of the letters, we turn that letter into an object where the object matches the shape, where the title is the letter. And so it's going to be something like title A, title B, title C. And the data is actually the data that we created up here. And so when we do contacts by letter, we pass it the letter. It just grabs that array. And then we can pass sections down here. And I'm missing. So in theory, now we have sections, which looks like an array, where for each array we have an object where the letter is the letter of the first letter of every single contact in its data array. And the data array, of course, is all of those contacts. And so now the moment of truth, when we toggle the contacts, we see A followed by a bunch of people whose first name begins with an A. And since there are 1,000 of them, there might be a lot of these. And let's actually simplify this. Let's make this 100. So now we see A, where we see a bunch of people whose name begin with A. We see B for Benjamin here, then C, and so on. Each one with a section header that corresponds to the first letter of all of those people. And if we want to style that, we could do so by just changing that render section header function. And so now we have something that looks almost exactly like the contacts list in your phone. Though there's one piece missing. What happens if you make a new friend? And so let's do that. Let's have or add some sort of way to add new friends to our list. And so what sort of things do we need in order to do that? We should probably have some sort of form where you grab somebody's name and you grab somebody's phone number, and then it should add that to your list. So let's go ahead and implement that. So that requires something called a user input, and so something that is often somewhat difficult to handle. And so there's a bit of a debate that goes on in the React community, more so React Web and less so React Native, of should we use controlled or uncontrolled components? And what do these things mean? Well, it's where exactly is the source of truth for the value of an input. And so if you imagine just an HTML form, you have an input where you can type into. That input now has a value, and who's keeping track of that value? And so controlled versus uncontrolled component is actually that debate. So in a controlled component, React controls what's in that value. Whereas in an uncontrolled component, it's actually controlled by the DOM itself. And so if you're writing some static HTML and you have something like an input tag, when you type into it, it retains the value that you type. That's because the DOM tracks exactly what you're typing. But in a controlled component, React is the one that controls that. And so if you imagine now in the React world, if you have an input, every single time you change that, React is going to have a variable that tracks that. And then what determines the value of that input? Well, it's whatever value React says that input should have. And that should correspond with whatever the value of the variable that React is tracking is. And so this goes back into the whole like who keeps track of the DOM debate. And so in React, you actually have no choice. You have to use the React virtual DOM, which will then write to the actual DOM. And same thing here. So who keeps track of the value of the user input? And so in a controlled environment, React does. You do as the person writing React. You say, every time this input changes, I'm going to update a value that I'm keeping track of. And what dictates what's inside that value? Well, it's what I say it is. And obviously, you just set that to whatever value you're keeping track of. And so we can see that example in the moment. React recommends always using controlled components. That way you have those values as JavaScript variables. That way if you want to submit a form or do some validation, you can do that all in JavaScript because you're keeping track of those variables in React and presumably in the state. And how do we actually create those variables? Well, you pass a prop called onChangeText to a text input. and you pass a value that determines what is the value of that input. And if you want to see other props that you can pass to text input, you can look at the doc page there. But let's do an example with those. And so in order to add contacts, we agreed that we needed some sort of way, some sort of page to do so. And so let's go ahead and write some page. So let's have this thing called an add contact form. And let's have this be a component. We're going to need a couple components like view, which we've seen many times before, and text input, which is what we'll be looking at today. And we're going to create this class. So this class is going to have in it a form where you can dictate what your user is. So in the render function, we're going to want to return a view with a couple text inputs. And then probably we're going to want some button to submit. And so now we have the shell of what is going to be the add contact form. And so just like in web or in any other project, you have a form that has a couple of inputs where each input refers to some value in your contact. So in the future, this is going to be the name. In the future, this is going to be the phone number. And of course, some way to add that user, to submit it. And so we have a button whereby we can add that contact. And so we can go ahead and expect that somebody already has implemented that add contact function. And so we can state that we're expecting a prop called add contact. And so when we submit this, we're going to just invoke that. But how are we going to keep track of the text inputs, those values? And so as you see on the slide, they expect two props. They expect a value, so something that determines what their value is, and how do you update that value? So a function called onChangeText. And so let's actually initialize the state. And I'll again use that shorthand for class properties, where we're going to have the name be blank and the phone be blank. And so what dictates the value of this one? Well, it's going to be the value in the state. And same with the phone down here. And now let's go ahead and get this form hooked up in our app. And I'm going to go a little bit fast for the sake of time. So import that. We're going to have in state, we'll say show form. We want to have some sort of way to toggle that. So let's call this toggle form. And we'll just say show form is opposite of show form. And now let's have another button. Let's get rid of the sort button and instead call it add contact. So now we have another Boolean flag, which is updated by a button, which toggles the form. And let's do this a quick and easy way for navigation. So if we should be showing the form, then just show the form. Otherwise, return the default. And so now we have this button called Add Contact, and when we click it, we see this other page, which we've partially implemented, which right now only has this Add Contact field. And so now let's go ahead and finish up that form. First, let's add some basic styling. Let's give the inputs some padding, a border, and now they should be a little bit more visible. And so now we should be able to see the inputs up there. Again, there's one that's way up there, so let's just add some quick style. So now we see those two inputs there. And if I type into them, nothing is happening. Why is that? Well, because right now React is the source of truth for the values of these text inputs. And what is the value? It's this.state.name. And what is the value of this variable? Well, it's a blank string. When does it update? Well, it never does, which is why no matter how many times I bash on the keyboard, nothing is updating in that text input. And so how now might we start to update this source of truth? Well, we need to tell it how to. So we need to create this function called update, or let's call it handle name change, which takes a new name. And it'll just do this .setState, the name. And same thing with the phone number change. So now we have a couple handlers. We have handle name change, which takes a name and just updates it in the state. We have a phone, which just takes the phone number and updates it in the state. And now all we have to do is tell those text inputs, hey, how do we update that value in the state? Well, on change text is this dot handle name change. And same thing down here. We have the value is state.phone, and the way to update the value is by calling this on change text, which is this dot handle phone change. And so now when you start to do this, it actually updates accordingly. Lastly, for the phone number, it doesn't really make sense for it to just be all letters. And so another prop that we can pass down is this thing called keyboard type. And we can say numeric. And if you want to see what other keyboard types there are, you can go ahead and look at the doc pages here. But now when we click the phone number, we see this. And so now we have a way to handle user input. And in future lectures, we'll talk about how to maybe validate that and how to handle stuff like that. And so on that note, I will close the lecture.